Hello, Algebra 2. Welcome to your fourth applied lesson. So we're going to get going. Just don't forget, at any point, you're going to go ahead and pause and write down what you need. I'll do some small explaining, but this is just mainly filling out your notebook right here. All right, so we're going to update your notebook's table of contents. We're going to put some notes on page 13 and 15. We're going to give you your next assignments. So here we go. Here's your table of contents. Go ahead and pause. These are your new ones. All right, so this is just some more notes on linear functions. So we're doing this over 2 days. So the big thing here is that there are two forms. So once again, you can pause and copy this down, but there's a standard form, which is where it has everything except the number on the left side. And there's a slope-intercept form, which we're all familiar with. So this first problem is in standard form right here, the way it's written. That 3x minus 8y equals 12. Now what we want to do is put that in slope-intercept form. So as you can see, we subtracted 3x from both sides. The negative 3x does not combine with the 12. It's got to be separated. Then you divide by negative 8. And a negative divided by negative is a positive. So you got 3/8x minus 1.5. You can leave that as a fraction. Now I do want to clarify. This 3/8x, I'm going to write it this way. Most people will write it like this, just to kind of keep it clean. And then of course you can see what the standard form do for you. Well, if you're in standard form, you can get your x and y intercepts real easy. If you remember, your x-intercepts are where the y is 0. So if you plug 0 into the y, it just makes it disappear. So you're left with 6x equals 9. Divide by 6 and you get 1.5. If you want to get your y-intercept, you put 0 into x. 6 times 0 is 0, so it's gone. And negative 3y equals 9. And then you divide by negative 3, and that's going to give you negative 3. So the work on here is it got a little messed up. Man, so let's write it over here on the side. 6x minus 3y equals 9. For the x-intercept, we're going to plug 0 into y. Well, look, if you multiply anything by 0, it's gone, so you just have this. So the way I actually do this, guys, if I want the x-intercepts, I just make everything with the y disappear because it's going to be a 0 in it. And this gives you 1.5. So that's the point, 1.50. So if I want the y-intercept, I'm just going to make the x disappear, so I just write down anything that doesn't have an x to it. So that's just negative 3y equals 9, divided by negative 3, x equals negative 3. So the y-intercept is 0, negative 3, because your x's were 0. The idea behind intercepts, guys, and you can do intercepts from any position. Doesn't matter what the equation looks like. If you want an x-intercept, make your y 0 and solve what's left. If you want an x-intercept, make your if you want a y-intercept, make your x 0. If you want an x-intercept, make your y 0. You make the other one disappear. All right. So now also, finding intersections of different graphs. We did this with a calculator last class. We can also do it algebraically. So when points cross each other, that's where the equations are equal to each other. So we can set equations equal to each other. So we know that if these two intersect, they are going to intersect where 3x minus 8 equals 2x plus 1. And we just simply solve that equation down. And you're going to get x equals 9. We then plug 9 into one of those equations, and we get the y value of 19. Okay, so one thing that we want to try to start emphasizing, we haven't talked about it a lot, is back here, apologize, clicked it too quickly, come on, go back, is to start filling in summaries. So on page 13, anything you kind of can pull out of it with a couple sentences, just sort of summarize what was on there in your own words. Now, how would you end up getting intersection of two parabolas? By graphing. So you can draw these by hand, but the graphing calculator is the best way to go with this. Go into your Desmos, type these equations in exactly as they are. So this 7 over here, man, this thing just didn't format well. Actually, is right here. So that'll help clean that up a little bit. And when you plug these in the Desmos, you can do y equals, or you can write it in function notation. Remember, it's not going to matter. And you can see the points that they intersect. They intersect at 1, -2, and 4, 1. Graphing is my favorite way to do it, especially with the Desmos calculator, because it takes all the work out of it. So now you're going to go to all your odd pages, as I was saying before, and you're going to do summaries. Just kind of summarize a little bit what was on that page. And this is such an important piece. This is what helps solidify your learning. All right, guys, that is it for that quick lesson. You will have a worksheet that's going to be sitting up in your assignments. It's a little pizzazz, trying to convert between standard form to slope-intercept, just to practice that out. Those go quick. And there's also going to be a little Kahoot on intersections. So with Kahoot, you're going to just click the link that's in the assignments. You're going to sign in with your Google. And when you're done, your score is going to be sent to me. So you don't even have to worry about it. It just makes it nice and easy. Hey, look, you guys take care, stay safe. Let's try to get these babies in by Monday night. Thank you.